All right, yesterday we started more application problems. We're doing 3 more. The first one we are doing looks like it's a distance equals rate times time, but after we read it, we need to look at what we're given and what we need to find. So before we trick ourselves into using distance equals rate times time, we need to look at all the information the author has given us. So a family is canoeing downstream, meaning if you have a river, the water is going, the rushing of the water, so the current is going with the canoe. So you have the canoe, the paddling of the canoe, plus you have the current. So there's where you have the canoe speed plus the current speed. So like yesterday we had the plane, so you had the air speed plus whatever the wind speed is. This would be the same concept. Their speed relative to the banks of the river averages 2.75 miles per hour. So this is downstream. This is with the current. During the return trip, they paddle upstream, averaging 1.5 miles per hour relative to the banks of the river. So now they're against the current. Find the speed of the current. So we have 2 variables in this problem. If we're simply finding the speed of the current, we have 2 types of speed. We have current speed, which we're going to call C, and we have the paddling speed, the family speed, or the boat speed, or however else you would like to call it. This is them. This is what the family's doing. This is their speed of the canoe. So, if they're paddling, when we go to write this problem, you're going to have them paddling plus the current is going to equal that 2.75. That's how we get the 2.75 miles per hour, because you have whatever they're paddling plus the current is taking them. If it says during their return trip, this time the current is working against them. They're paddling, and then that current is working against whatever efforts they're doing, and you get 1.5 miles per hour. And then you have your 2 systems. You have your whole system. You have your 2 equations. Elimination is the easiest, and you can tell that they're going to eliminate simply by adding. You could have subtracted. I'm going to add and get rid of the C's. So I'm going to be left with 2p equals 4.25, and then we would have to divide both sides by 2, and p will equal 2.125 miles per hour. And that is how fast they are paddling. And then it said find the speed of the current. Well, we could take that p and substitute it in either place. So we could take that p and substitute it in here, or we could take it and substitute it in there. And when we do that, we are going to get that the current speed is equal to 0.625 miles per hour. All right, that was our next type of problem. The next one is called a ratio problem, and there'll be a couple of these in your homework. What you're going to do is one of your equations in the system is going to be a ratio. The other one's going to be a normal problem, but one of them is going to be a ratio. So it states, suppose the ratio of girls to boys in your school is 19 to 17. So it gives you the ratio right here. It tells you girls to boys is 19 to 17. Oops. So when you go to write this, you're literally going to take, I'm going to call girls G and boys B. I am going to write G over B and that's going to be equal to 19 over 17. So girls to boys, girls over boys, is to 19 over 17. So my first equation part is a ratio. It says there are 1,908 students altogether. So my second equation is girls plus boys equals 1,908. Now when I do a ratio problem, the first thing I would suggest is to get this out of a ratio and into a regular equation. So I'm going to cross multiply and I'm going to have 17G equals 19B, and I'm either going to solve this for G or B, or I'm going to solve this for G or B and use substitution, because substitution would be the easiest one for this type of problem. I'm choosing to do this one for G or B. So we're going to solve this for G by subtracting B from both sides. And I'm going to have G equals 1,908 minus B. And I'm going to take that and substitute it in here for G. And so then I'm going to have 17 times 1,908 minus B equals 19B. I'm going to have to distribute the 17. So 17 times 1,908 equals 32,436 minus 17B equals 19B. I'm going to add 17 to both sides. So 32,436 equals 36B. Divide both sides by 36. So 901 equals B. So there are 901 boys, and that number gets substituted in for boys to find out how many girls. So there are 1,000, girls equals 1,007. So for ratio, you set up a ratio as one of your equations, but you need to make sure you cross multiply and get it into a standard equation. And then you're going to have to use substitution. All right, and the last one is a distance problem. Suppose it takes you 6.8 hours to fly about 2,800 miles from Miami to Seattle. At the same time, your friend flies from Seattle to Miami. His plane travels with the same average airspeed, but his flight only takes 5.6 hours. Find the average airspeed of the planes. So when I look at this, it didn't tell me who's going with the wind and who's going against the wind. But I'm going to analyze it and say that, well, it's taking my friend longer than it's taking me. Therefore, I am going with the wind. It's taking me quicker to get there. So when I go to make this is my friend. And just like yesterday, distance equals rate times time. So I have my friend, and the distance is 2,800, and I'm going to have my distance, and my rate is going to be the plane speed, which they call airspeed, so A, and we have to take away the wind speed because the wind speed's coming at it and it's hindering us. That's why it took him longer. This is the friend. So airspeed minus wind speed is the rate times the time was 6.8. Me, same distance, and instead of against, I'm with, so I have the airspeed plus the wind speed. That's why I'm traveling faster. 5.6, I'm going with it. I get to add on that wind. It's the extra boost. Yesterday I told you a helpful hint. These are just two numbers being multiplied together here. This is a number, this is a number. Get rid of the decimal by dividing both sides of the equation by 6.8. In this one, I divide both sides by 5.6. So here I would take 2,800 and I would divide by 6.8. And I would get not a pretty number. I would get about 411.8. And I'm going to round. Equals A minus W. And then here I'm going to do the same thing. I'm going to take 2,800 and I'm going to divide by 5.6 this time, and I get 500. And that equals A plus W. And now I am capable of easily doing addition or subtraction in order to eliminate. And I'm going to add and eliminate the W's. So 411 plus 500 is going to give me 911.8 equals 2A. And then I'm going to divide both sides by that 2, and I will have 455.9 equals A. And that is the average airspeed. The average wind speed, then, I would have to take that and substitute it back in for A. And I would get 44.1. miles per hour.